This is the solution to Integrity's November XSS challenge. Hey everybody, and welcome to this write-up of Integrity's November XSS challenge by Harel. So Harel created this challenge. It is an absolute banger of a challenge, so I'm very happy that I can show you guys the solution. But before I get into that, be sure to give Harel a follow on Twitter, and while you're at it, also follow Integrity so you don't miss out on these challenges in the future. If you haven't yet given this challenge a go, then be sure to do it visiting the link shown right here. But now, without further ado, let's check out this application. So if we go to the link, we see that we have a login screen where we can register and log into an account. We then see that this is a notes application. We are allowed to save notes to this application, our private little notes. We can also upload a profile picture. And those are really the main features of this application. There's not much more to it, but there is a lot to hack. So let's check out how we can hack this website. One thing we can notice while looking into this challenge is that our profile picture is stored on a different domain. So if I open this in a new tab, you can see that currently we are on the api.challenge domain, but the image is stored on a CDN, the cdn.challenge domain. Okay, so that is quite interesting. The same is true for our nodes. So I currently have my test node open. If I go into the inspector tools, then I can see that this is an iframe with a source of cdn.challenge. So our important data, our user data, is not stored on the API domain, it's stored on the CDN domain. And that is quite interesting and something we may want to look into. So I opened the CDN domain, or a request to the CDN domain in burp. And here you can see we're getting /uploads/subscribe.png. And if I send that request, we get a 404 with a smiley face, and it says, could not find this specific path. Okay, we have something being reflected here. One more thing to note about this request or this response is that we get an Xcache header. So there is also some caching going on this CDN. So interesting stuff going on here. The first thing that I want to look into is this reflection here. It should be really easy to just check if things are being sanitized when they're being outputted. And well, what if I enter a script tag? We see that the script tag appears without being encoded or sanitized in any way. That is quite interesting. So can I just have a script tag with an alert of 1 and then close the script tag? Is that possible? Oh, it doesn't seem like it's possible. This time we get an error and it says cannot get that file. Whereas earlier we saw something different. We saw a 200 OK and a 404. So there's something interesting going on, and it all has to do with the slash in our script closing tag. Because if I add a slash here, now we get that other error. Because probably Express is set up to listen for a file in the uploads directory and not a directory in the uploads directory. So okay, we cannot have slashes in our file name, but that shouldn't really matter because we can just have a get parameter with a script tag. That's going to do an alert and then close that script tag. This should be fine, right? And yes, it is fine. This is still a file in the uploads directory. So this triggers that seemingly custom 404. And it has a script tag here, which is not sanitized or encoded in any way with an alert. So, I mean, this should be a fairly easy XSS, right? I'm going to copy the URL in burp and open it in the browser, and hopefully we will get that nice XSS pop-up. But we don't. We get that 404 message again, but this time our payload is encoded. Why is that happening? Well, let's open the inspector tools once again, go into the network tab and reload this page. And now we see that with this request, the request URL is already encoded. And that is because the browser will, well, URL encode all of this. And that is something that we don't want because the server is not doing any URL decoding. It's literally just taking the input it gets and outputting it. But we cannot within the browser just in the URL send a script tag that is not URL encoded. So that is quite a bummer. So we have to go back to the drawing board. And back in Burp, I get reminded of this Xcache response header. There is some caching going on here. What if we could find a way to cache a response that has a valid XSS payload? If we cache that and then we're able to hit that cache in the browser, would that be possible? And well, we can try to cache this, for example. So if I send this request a couple of times, it should get the Xcache to hit, but it doesn't, so it always misses. So we're kind of not hitting the cache keys here. So the cache is set up to cache a certain type of request, and apparently this type of request it doesn't want to cache. If we remove our script tag, however, it does start caching. It does start hitting the cache. So is it just that the get parameter is not allowed? Well, perhaps. But if you play around with this and you have some automated tools that can do some scanning here, you will find that if you just append a .png as a get parameter, that will hit the cache. So it seems that the only check that is in place here is to check if it ends in .png. So if I send this, for example, it will first miss because there is no entry for this in the cache, but now it should hit, and it does, and now we have cached our payload here. But one issue is obviously the browser. If we just send this request to the browser will URL encode all of this. And that is not what we want, because perhaps it won't hit the cache then. And that is one thing that we have to check out. And we can do that in Burp. So all we have to do is just URL encode all of this, send it, and we see that it still hits the cache. So that's cool. The output that we see is literally our input, not being URL decoded, but it seems that when it goes into the cache, it does properly URL decode, and that is because they're probably using Varnish here, and probably Varnish has implemented that correctly, whereas the custom 404 page hasn't. So that is very interesting. We're hitting the cache with this. So let me un-URL encode that, or decode that as they call it, and then copy the URL and try that out in the browser and see if we have an XSS. And we get our alert, we get our magical pop-up saying that we have an XSS. That is super cool, but it's not yet the end of this challenge, because the goal is to get the flag, and we don't have the flag yet. So what's up next? Another functionality I want to take a deep dive into is the file upload functionality, because we are able to upload profile pictures. And I've quickly captured one of those requests in Burp here. And as we can see, it's a post request to the API, and it does some things. Here is your image. We can see that the file name is index.jpg, the content is image/JPEG, and then we have our content. And if I send that request, we see we have a success set to true, and our avatar path is then the path on the CDN where we can actually find our image. That is interesting. We are able to upload images, but are we able to upload other files? For example, what would happen if I just upload this image but as a JavaScript file? So if I send this as a JavaScript file, then we see that we get a success, and now the avatar path is a JavaScript file. It ends in JavaScript. The content type is still image/JPEG, but the file seems to be, or the extension is now JavaScript. So what will the browser think of that? Well, let's visit this. And now, well, this is the image, but then I guess the browser wants to view it as a JavaScript file. That is very interesting. Can we actually put some JavaScript in here? Like, what happens if I change the contents to be just an alert? All right, well, let's try to send that. Now I want to visit this URL. And if I visit it, wait, I get the same thing back. Ah, yes, of course. There's a cache here. The cache is caching it. So if I just bust the cache by adding like a question mark A here, now we see that we get our alert 1 as JavaScript, even though the content type is different. Now, can I use this JavaScript file? Like, will that work? Well, it's easy to test. We already have an XSS. So this is the thing we were playing around with earlier, where we have our request that gave us an XSS. So in this case, I just have a script tag with a source to our JavaScript file that we just created. I'm going to send this. Now I get, well, the payload is cached here. Now I just have to copy the URL and open it in the browser. And then we see that we get our pop-up. So that means that this actually works and that we are now able to upload any kind of files that we want. Obviously, if this was a PHP application, we would upload PHP, but this is not, this is Node.js, so that makes it a bit more difficult, but this is definitely something that we should remember and use whenever we get a chance to. But still, we haven't really gotten further in this challenge. So let's see if we can tie these two findings that we have right now together. So we now have an XSS and a way to upload a file on the CDN domain. What can we do with all of that? Well, not really a lot, it seems. It's very hard because we have this XSS on this page where really nothing interesting is happening. It's just an error page. There's nothing really interesting happening on the domain, but there is something stored there of, for example, the admin user or other users. And one idea that can come to mind is to use service workers to exploit this and to see what your victim is accessing on that domain. Now, what is a service worker? Well, the idea is that it's kind of a proxy between the client and the server, or maybe even the browser, where with every request that you send, a service worker can kind of come in between and check out that request and, for example, check if you have internet access. If not, then it can tailor your experience based on all of those things. So all in all, fairly interesting. And you need two things for that. First of all, you need some JavaScript code that is going to register the service worker, and that is going to point to a JavaScript file which actually contains the code for the service worker. And we, in this case, have both of those things. So that is obviously very interesting, and this could be a way in here. So it's definitely worth playing around with. So let's take a look at what I have set up here. So first of all, I want to take a look at the service worker code here. So what will this do? This is very short, very easy. We're going to add an event listener and listen for a fetch event. So every time the client tries to fetch something from the scope of the service worker, in this case, the uploads directory of the CDN domain, then we are going to do something. And what are we going to do? Well, I'm going to fetch my own attacker control domain. And I've set up my ngrok here in my terminal. So I have the ngrok up and running and then a listener on a local port. And this will just kind of show us the requests that come in. So that way we have like kind of a sense of what is coming through. But then as a get parameter to that request, I have the URL of the request that we're receiving. And that way we can actually see what URLs are being accessed, or that's the idea at least. Then besides that, we also have our code that is actually going to register the service worker, and that's this little piece of code. So it's going to register a service worker. This is then going to be the path to the JS file. And when it registers, it's then going to set the location of this page to the API. Why? Well, the API, when it loads, it logs you in and it shows you your main dashboard with your nodes and your avatar. And those nodes and that avatar comes from the CDN domain. So this way, all of that is loaded after registering the service worker. And that way we will actually, or the client is actually forced to make those calls. So we will see that stuff happening. So, okay, let's try this out. Back in Burp, I first am going to create a file. So as you can see, just like earlier, we create a JavaScript file, and this is going to have the service worker code that I showed earlier. When I run that, you see that we get our avatar path. So I've copied this and I've put this over here in our XSS here. So we have our scripts.png, and this is just going to do that code that I showed you earlier. So if I run this, we miss the cache. Now we hit the cache. That means we can now copy the URL, and let's see if our user will work with this. So we run it, we get redirected, that all worked. Let's take a look at our listener, and we see that we actually got a callback here. So the first callback is actually the one registering the service worker, it seems. So we get that. But besides that, we also get this one. And this one, let me quickly grab that URL and copy it here in our notes. This one is a call to the CDN, to the uploads directory, which is going to get a node from my account and then the full ID of this node. Okay, very interesting. So through this, we actually get some information. We get, for example, the name of the account that we're targeting, so their username, and the full URL of an ID. That is very, very interesting. Perhaps we can actually try out the same with the admin, because there is an admin account running here. We don't know the admin's username, but as explained here, we can access the admin through the API. We can give it a URL. So right here, if we give it a URL, the admin will visit it, and that way we will maybe see some interaction from the admin. So let me quickly clear this. And now I'm going to make sure that we have this cached again, copy the URL, and feed it to the admin. Okay, the URL has been sent, and we immediately get a callback. We get a URL, which is very, very exciting. So let's copy this once again, and let's take a look at this one. What do we see here? Well, we see again, the admin tried to contact the CDN. In the uploads directory, it tried to access a node. We have a username of an admin, and then we have the ID of that node. Okay, very interesting stuff. Now, one of the first things that I want to check is there maybe an IDOR here? Can I actually read this node just from having it? So if we go and curl that, so let me quickly quit this and let's curl this, then we see that we actually get some outputs. We can read the admin's node, so hopefully this will contain the flag. And this says, so a p tag, style is color white. If you are reading this, it seems like there is a vulnerability in my website. Good thing I hid the flag in my profile picture, so you will never find it. Okay, that is a bummer. The flag is not in the node of the admin, but apparently in the profile picture of the admin. So it seems like we still have to do some work in order to actually get the profile picture of the admin, because earlier we did not see any callbacks for loading in the profile picture of the admin. So something interesting is going on there. It's seemingly not coming from this uploads directory. So we still have some work to do, but we are getting very close. Now is probably a good time to tell you that there is another environment. We have this API, but we also have a staging-.challenge.integrity.io. And when we go there, we see you are in the staging environment. And this was also hinted on Twitter. So if you didn't find it yourself, you could have found it that way. It was a very clear hint. But we have a staging environment and we have our API environment. Sometimes, very sometimes, developers don't properly division up their environments. So their main environment, their production and staging might be sharing something in the back, and that can be very dangerous. For example, what happens if a JWT key or secret gets shared between the backend and the front end? Well, that would mean that if we sign up as the admin here and get the JWT token, that JWT token would also work on the main domain. So that is something we definitely want to try out. So I'm going to go in the inspector tools here to quickly make sure I can type the username in here. So remove the read-only field there. Type the admin username in there that we got from the admin's node. I'm going to set up a very secure password. Sign up. We have signed up as the admin on the staging environment. Now we log in. That works. We are in a staging environment. We are logged in. We now have a session token. So if we go into the local storage, we have our JWT token. I copy that. I go to the main domain where I'm currently ping draconian. And I'm going to go and change up my current JWT token with the one I just got from the staging environment. Now, if this is secure, then this doesn't work and I get shown the login screen again. But if this works, then I'm logged in as the admin. And when I do, we see that I am logged in as the admin and that the admin has a profile picture. I can open that picture in a new tab. Here we have a beautiful monkey. The note, we can also read the note. It says, if you are reading this, it seems like there's a vulnerability in my website. Good thing I hit the flag in my profile picture. So, okay, we need to get the flag out of the profile picture. Let me save this image in my downloads folder. Okay, I'm not sure where I saved it. Let's save it again. Okay, it is in my downloads folder. That's great. Now, what I'm going to do is I'm going to, it's hidden inside of that picture. So let me quickly move it here. So downloads avatar .jpg here. Now I can like cat this and we can probably see a lot of stuff. We can do like strings on this. Maybe it's hidden somewhere in there, but obviously this will produce a lot of junk, so that's not necessarily useful. But up here in my strings command, we see that it prints out something that looks a lot like a flag. And actually, as you can see above here, this is in the XIF, so let's quickly show that in a better way. So if I run XIF tool on this avatar, then we will see that there is an artist value set here, or an artist key with a value that has the flag integrity, working hard, or hardly working. And that was the solution to this challenge. What an insane challenge this was. I absolutely loved it. So a huge thanks, Harald, for creating this. Now for a quick little recap, we signed into this notes application and we found a cache poisoning vulnerability. Using that cache poisoning vulnerability, we were able to exploit an XSS, which, well, we already found, but we couldn't yet exploit. But together with a file upload vulnerability is where the real power came in, because we registered a service worker, and through that service worker, we were able to read what files our victim was loading from the CDN. Through those files, we figured out his account name, the admin's account name, and that led us to a new path where we used the staging environment to sign up as the admin, and then we noticed that the JWT secret key was shared between the two environments, which allowed us to log in as the admin on the main environment and get the flag. That was this challenge. I absolutely loved it. If you loved this video, then be sure to like it, because this marks the end of the video. Like, subscribe, and if you want to ask any questions in the comments, then please feel free to do so. Also, follow us on Twitter if you don't want to miss out on any of these challenges in the future. I'm Pink Draconian from Integrity, signing off. Have a nice day, everyone.